We pray for better days.
Dear students, welcome back to today's Vidyanagar online science class. I'm here with you to continue our 12th chapter, electricity. And in today's class, we are going to discuss about factors on which resistance of a conductor depends. Factors on which resistance of a conductor depends. Shall we begin our today's class? Okay. So, we are going to discuss about factors which depends the resistance, or which are the factors which affects the resistance, and the factors are length, area of cross section or thickness, and nature of the material. So the factors which affects the resistance are length, area of cross section or thickness, nature of the materials. Which are the factors which affects the resistance of a conductor? Length of the conductor, area of cross section or thickness, nature of the materials. Length, area of cross section or thickness, nature of the material. These are the factors which affects the resistance of a conductor. Now we are going to compare these factors, which means how these factors affects the resistance and what are the changes these factors make on resistance. Okay, so we can start our today's class with the help of an activity. Okay, as I told you, the factors which depends the resistance are length, area of cross section or thickness, or nature of the materials, right? Okay, so you can see a circuit, electric circuit on the board which contain a battery, an ammeter, a key, and the connection wires, etc. And also you can see a gap here, right? So we are going to use our materials on these gaps, right? So first I am going to place a nichrome wire of length L. So what I am going to fix here? Okay, you can see a gap. So in this gap, I am going to fix a nichrome wire of length L. Nichrome wire of length L. So what I kept here? I kept a nichrome wire of length L. Then what I have to do, you see, I have to measure the current from ammeter. So first I have to place a nichrome wire of length. You see, keep it in your mind. So the length and all, concentrate in your mind. Okay, so first I fixed a nichrome wire of length L. Nichrome wire of length L. Then after I have to measure the ammeter reading. From ammeter reading, which means I have to measure the current from the ammeter. Then I have to record somewhere. Okay, so that's the first step. So in the first step, I have to fix a nichrome wire of length L. Then after I have to measure the current from the ammeter. Okay, so that is the first step. And in second steps, I am going to replace the nichrome wire of length L and I have to fix the nichrome wire of length 2L. Okay, so now I increase the length and the length of the nichrome wire become 2L now. So in the first case, I used a nichrome wire of length L, and the second step I replaced the nichrome wire of length L and I have to fix the nichrome wire of length 2L. So in the previous case it was L and the present case it is 2L. So you have to note that difference. Okay. So in the first step nichrome wire of length L and in the second step nichrome wire of length 2L. Okay. I have to measure the ammeter reading and I have to record somewhere. And in the third case, I have to increase the thickness of the wire. I have to increase the thickness of the wire, right? So what I did now, I have to increase the thickness of the wire, right? Okay. So in the third case, I used the same nichrome wire with the double thickness. So earlier the thickness was very less, but in the third steps the nichrome wire I used has a great thickness, or it has some thickness now. And as usual, measure the ammeter reading and record somewhere. And in the fourth step, replace the nichrome wire by a copper wire. So remove the nichrome wire from the circuit and place copper wire. So assume this is a copper wire. Okay, copper wire. So 4 steps, right? So in the first step, you have to use the nichrome wire of length L, then measure the ammeter reading. Second step, use the same nichrome wire but the length make doubles, 2L, nichrome wire of length 2L. And in third step, nichrome wire with the more thickness, you have to use a thicker wire and record the ammeter reading. And in fourth case, remove the nichrome wire and fix a copper wire and measure the ammeter reading. Okay, let me repeat it. First you have to use the nichrome wire of length L. In second step, replace nichrome wire of length L by the nichrome wire of length 2L. And in third step, replace the nichrome wire of length 2L and place the thicker nichrome wire. And in the fourth case, remove the nichrome wire and fix a copper wire. And in these cases, we have to record the ammeter reading. And with the help of this ammeter reading, we are going to find some relationships. Okay, so what we are going to discuss now, we have to find the relationship between these factors and the resistance. Okay, so let's see what happens there. It is observed that ammeter reading reduces to half when the length of the wire is doubled. What? The ammeter reading reduces to half when the length of the wire is doubled. So when we increased the length from L to 2L, what changes happen there? The ammeter reading suddenly reduces to half. When we increased the length of the wire, you can see there is a reduction or decrease in the ammeter reading. Decrease in the ammeter reading means decrease in the current. Got it? Ammeter reading decreases to half when the length of the wire is doubled. When we increase the length of the wire, you can see there is a decrease in the amount of current. When there is an increase in the length, there you can see the decrease in current. Decrease in current means how can we connect this decrease in current to the resistance. So we have discussed in our previous class that resistance increases, current decreases. Resistance increases, current decreases, and resistance decreases, current increases. So resistance and current is in inversely proportional relationship. When there is increase in the current, there is decrease in the resistance. Keep it in your mind, okay? When resistance increases, current decreases. When resistance increases, current decreases. When resistance decreases, current increases. When resistance increases, current decreases. When resistance decreases, current increases. So current and resistance is inversely proportional relationship. Okay, so how can we connect this in our present case? When we increase the length of the wire, we can see there is a decrease in the current. Decrease in the current means reduces to half. Current reduces to half means, or current decreases means, how can connect this in terms of a resistance? Current decreases means resistance increases. Got it? In which case current decreases? Current decreases when there is an increase in the resistance. Got it? We started from the length, okay? The ammeter reading reduces to half when the length of the wire is doubled. When we doubled the length of the wire, you can see there is a decrease in the ammeter reading. Ammeter reading reduces to half. Ammeter reading reduces to half means current reduces to half, or current decreases. When the current decreases means indirectly you have to know that there is an increase in the resistance. When there is an increase in the resistance, you can see the decrease in the current, right? That we discussed earlier. When resistance increases, current decreases. So what happens to the current here? Definitely the current is decreases, right? Current decreases means resistance increases, right? So when the resistance increases when we increase the length, Right? How we got that point? Resistance increases. Resistance increases because we increased the length of the wire. Which means length and the resistance is directly proportional relationship. R is proportional to L. Got it? How R is proportional to L? Because, okay, so before that, we can use the L for the length and A for the thickness. Okay, so which letter we can use for the length? L, and the area of cross section or thickness A. Okay, so we started the sentence like this. It is observed that ammeter reading reduces to half when we increased the length of the wire, or when we doubled the length of the wire. Okay, so when there is an increase in the length, you can see there is a decrease in the current. Decrease in the current means increase in the resistance. So why there is an increase in the resistance? Because there is an increase in the length, which means L increases, R increases. It is coming like no. L increases, R increases. L increases, R increases, but middle one point is the I reduces. L increases, I reduces, R increases. 3 points. L increases, I reduces, R increases. Which means L and R in directly proportional relationship. So that is the first point you have to understand. How the length and resistance connects. How the resistance and length connect. Length is directly proportional to resistance. Length is directly proportional to resistance. Got it? Directly proportional to L. Which means length increases, I decreases, R increases. 3 points. Length increases, I decreases, R increases. Length increases, I decreases, R increases, which means R is proportional to L. Next one, ammeter reading increases when a thicker wire of same material and the same length is used in an electric circuit. Ammeter reading is increased, or ammeter reading increases when a thicker wire of same material and the same length is used in an electric circuit. Which means when we use the thicker wire, there you can see there is an increase in the ammeter reading. When we used the thicker wire, the ammeter reading increases. When we increase the thickness or the area of cross section, there you can see the increase in the current. Increase in the current means R increase in the current, or amount of current increases, R decreases. R decreases, I increases. That is our connection now. R decreases, I increases. R decreases, I increases. So here ammeter reading increases or I increases, which means R decreases. Why R decreases? Because we changed the thickness. Which means thickness or area of cross section is inversely proportional to the resistance. How? Because ammeter reading increases when a thicker wire of same material or same length is used in an electric circuit, or which means when we change the thickness or when we increase the area of cross section or thickness, there is an increase in the ammeter reading. Increase in the ammeter reading means there is a decrease in the resistance. Increase in the ammeter reading or increase in the current means decrease in the resistance. So the resistance is inversely proportional to area. So how the resistance affects the area? Area increases, R decreases. Or R decreases, area increases. So one increases, other decreases. One increases, other decreases. Which is the proportionality sign? Inversely proportional, which means area of cross section or thickness is inversely proportional to resistance. Got it? When we change the thickness, there is an increase in the ammeter reading. Ammeter reading increases means I increases. I increases means R decreases. R decreases in case of a thicker wire. in case of an increase in area of cross section, which means area of cross section increases, resistance decreases. Area of cross section increases, resistance decreases. One increases, other decreases is an inversely proportional relationship, which means R is inversely proportional to area of cross section. I told you which symbol we can use as the thickness, area of cross section. So R is inversely proportional to thickness. So R is proportional to length. Length increases, I decreases, R increases. Okay, area increases, ammeter reading I increases, R decreases. Area increases, I increases, R decreases. Length increases, I decreases, R increases. Area increases, ammeter reading also increases, R decreases. Okay, so these two equation is very important. And the next step, we have to join these two equations or consolidate these two equations, because both are proportional. So on joining, what we get, R is proportional to L by A. On joining these two, R is proportional to L by A. Then normally our next step is to remove the proportionality sign. So here that proportionality sign is R equal to rho L by A. So here this is the proportionality constant rho, R H O. What is the pronunciation? Rho. Rho means what? It is proportionality constant. So here R is proportional to L by A. Here R equal to rho L by A. This proportionality constant is resistivity. What is this proportionality constant? This is rho. That proportionality constant is resistivity. Okay, so which is this proportionality constant? Rho. So R stands for resistance, rho resistivity, L length, A area of cross section. So this is very important equation. Okay, so the equation which connects resistance and resistivity. The equation which connects resistance and resistivity. This is the equation. R equal to rho L by A. R stands for the resistance, rho stands for resistivity, L for length, and A for area of cross section. So we started from here. R is proportional to L. Why? L increases, I decreases, R increases. And area increases, ammeter reading increases, R decreases. On joining these two, R is proportional to L by A. And next step is to avoid the proportionality sign by keeping a constant. So that constant is rho. R equal to rho L by A. And this proportionality constant is resistivity. This proportionality constant is resistivity. Okay. R equal to rho L by A. R is resistance, resistivity, length, area of cross section. Okay, now we are going to make an equation for rho. How to make an equation for rho? First you cross multiply these two. R into A. R into A equal to rho into L. Rho L. Then rho L equal to R into A. Okay. Then rho equal to what? R into A by L. Rho equal to this L will come out. Be out, down. Okay. O R into A by L. So this is the equation for rho. Rho equal to R A by L. Rho equal to R A by L. So this is the equation for resistivity rho. Rho equal to R A by L. Okay, the next step, we can substitute the units of these. What is the SI unit of resistance? Ohm. Ohm is the SI unit of resistance. And what about area? Area equal to meter square. The SI unit of area, meter square. And what about L? Meter. Okay, then cancel. So you get rho meter. So rho meter is the SI unit of resistivity. So what is the SI unit of resistivity? Rho meter. Not rho meter, ohm meter. What is the SI unit of resistivity? Ohm meter. The SI unit of resistivity is ohm meter. How we got that? First we have to give the SI units of these. Ohm, meter square, meter. So I cancel. then we will get ohm meter. So what is the SI unit of resistivity? Ohm meter. And the SI unit of resistance? Ohm. And the SI unit of resistivity? Ohm meter. Okay, don't change it and keep it in your mind. Okay, so the SI unit of resistivity, ohm meter. SI unit of resistivity, ohm meter. SI unit of resistivity, ohm meter. Okay, so the last factor is nature of the material. Okay, and in the activity I told you, at last we have to replace the nichrome wire by the copper wire, no? So definitely by changing the copper wire, by replacing the nichrome wire, and we have to fix the copper wire, no? So there you can see the difference in the resistance, which means by changing the material we can change the resistance. Changing the nature of the material means what? Changing the material we can change the resistance, which means nature of the material affects the resistance. Nature of the material affects the resistance, which means by changing the material we can change the resistance, which means nature of the material depends the resistance. Okay, so and which is that very important equation? Two equations are there. R equal to rho L by A and rho equal to R A by L, and the SI unit of resistance ohm and the SI unit of resistivity ohm meter. SI unit of resistivity ohm meter. Okay, SI unit of resistivity ohm meter. Rho is a constant of proportionality and it is a characteristic property of a material. Both the resistance and the resistivity vary with change in temperature, which means both the resistance and the resistivity changes with change in temperature. And I told you the proportionality constant rho is called resistivity and its SI unit is ohm meter, and it is a characteristic property of a material. And both the resistance and the resistivity change with changes in temperature. Okay, and also you can see a box on the screen. There you can see the resistivity of conductors, alloys and the insulators. And from the table it is clear that resistivity of conductors and alloys are very less. Conductors and alloys have very less reactivity, which means they are good conductors of heat and electricity. Good conductors of electricity. So the resistivity of conductors and the alloys are very less, so they are good conductors of electricity, and that of insulators, they have higher resistivity, so they are poor conductors or insulators of electricity. Okay, and another very important point, alloys do not oxidize. Alloys do not oxidize or burn on high temperature. Alloys do not oxidize or burn on high temperatures. Alloys do not oxidize or burn on high temperature. Because of this reason, alloys are commonly used in electric heating devices like electric iron, toasters, etc. Why alloys are used in electrical devices, heating devices? Because alloys do not oxidize or burn. It have the capacity to hold more amount of heat. Do not oxidize or do not burn means what? It have a greater capacity to hold the temperature. Okay, so it can, up to a great extent it can tolerate the heat. That's why alloys do not oxidize or burn on high temperature. That's why alloys are commonly used in electrical heating devices like electric iron, toasters, etc. And tungsten is commonly used for electric filaments. Tungsten is used to make filaments in the bulb. So which is used to make the filament? Tungsten. Tungsten is used to make the filaments in electrical bulbs, and that of copper and aluminium used for electrical transmission lines. electrical purposes, electrical wires, for making electrical wires. So tungsten for filament and copper and aluminium for electrical transmission lines, and alloys do not oxidize or burn on high temperature, so they are used in electrical heating devices like electric iron and toaster, etc. And both the resistance and the resistivity changes with change in temperature. Okay, so which are the factors which affects the resistance? Length, area of cross section or thickness, or nature of the materials. How the length depends the resistance? Length is directly proportional to resistance. When length increases, I decreases, R increases. Length increases, I decreases, R increases. And in case of area of cross section or thickness, area of cross section increases, ammeter reading increases, R decreases. So R is inversely proportional to area of cross section. Area of cross section increases, I increases, R decreases. So R is proportional to 1 by A. And last one, nature of the material. Okay, by changing the material, there is change in the resistance, which means nature of the material also affects the resistance. And on consolidating these three, we get R equal to rho L by A, and rho is a resistivity, proportionality constant resistivity, and it is a characteristic property of the material, and the SI unit of resistivity is ohm meter. That's all about today's class. See, all the points that we discussed in our today's class is very important. So keep it in your mind and watch the video carefully. We will meet you soon with another video. Until then, it's bye. Thank you for watching. Have a great day ahead.